Hi, this is Mr. McGovern, and this is the fourth video in the acceleration series where I'm going to look at an NCEA example. In fact, I'm going to look at an example of my own first and then get into an NCEA problem. So the reason I'm giving you my example, where a car accelerates from rest, it travels a distance of 200 meters in 10 seconds, calculate the car's acceleration during this time. The reason I want to look at this is because it's a common mistake that's made. And so I'll go through why it's wrong. So the wrong way would be to do the following. Would be to say, okay, I've been given some information. What have I been given? Distance 200, time 10 seconds, and find the acceleration. Let's look for an equation. I really need the velocity to work out the acceleration, so I'll work out the velocity first, distance over time. So distance over time is 200 meters divided by 10 seconds gets me 20 meters a second. And then from that, I can work out the acceleration velocity over time, which is 20 over 10. Gets me 2 meters a second, or it should be squared for my acceleration. Bearing in mind this is the wrong way, right? So why is it wrong? The reason why it's wrong is you've made a big assumption there when you just went formula hunting. So you just wrote down what you knew and just straight away tried to do a calculation without really understanding the physics. The issue is that in writing down distance equals 200, time equals 10 seconds, you've ended up picking the formula, velocity equals distance over time, that only deals with constant velocity situations. It's not an acceleration formula, and so you can't use it in this situation. And that ends up screwing up your answer later on down the track. So you can't do that at all. The correct method, and we're going to do it two ways, using graphs and using equations, just like I have in my previous examples, is always start with a motion map. Okay? Once you get the motion map out there, you clearly see that this car is accelerating. We have acceleration arrows, it's a constant acceleration. This means I've got my velocity is increasing. I know in this case my velocity is positive, my acceleration is constant, and my acceleration is positive as well. Using this information, if you wanted to use the graphical method, I draw myself a displacement time, or position time graph, sorry. I know it goes a total of 200 meters in 10 seconds. My velocity time graph, I don't know what velocity it goes to, but it changes its velocity, and it takes 10 seconds to change it. I don't know what my acceleration is as well. So let's get between graphs. We know that if we can take the gradient of that position time graph, we can find the velocity. The issue with trying to take the gradient in the position time graph is that gradient, the steepness, is changing. At any point it's different. It's actually very difficult to do without calculus. However, I know I can work backwards if I have my velocity time graph and work out the area. And I'm going to do this one in a sort of a backwards way. So the area of my velocity time graph is a triangle. To work out the area under that is a half base times height. But I know the area. It's 200. That's the distance it goes. So 200 meters is a half. The base of that triangle is 10 seconds, and I don't know the height, which is my final velocity. So I just do some rearranging, and I end up getting 40 meters a second. That's my final velocity. Now that I've got that, I can move between this velocity time graph and the acceleration time graph because I know that the gradient of that graph is acceleration. The good news is it's the same gradient everywhere. I only need to work out the gradient once, rise over run, and it's 40 because that's its rise, divided by run 10 gives me 4 meters a second squared. So that's using the graphical method. I can also use the equation method. Start with a motion map, make sure I know my velocity is increasing, it's positive, and what my acceleration is as well. Then as I look at these equations, knowing that I have an acceleration here, I can straight away write down what I know. It accelerates from rest, that's initial velocity 0, travels a distance of 200 meters in 10 seconds, and I want to find acceleration. Straight away I can block out that one. Block out my constant velocity formula because I don't want to use it. So what formula has the rest of those four things in it? It's this one here. So put that in, put my numbers in. My initial velocity being 0 makes this simplify down quite easily because 0 times 10 is 0, and then I just have to rearrange and I get the same answer as I had before. So again, if you're trying to be a really top student, you can do it in two different ways to make sure you get the same answer. Here's an NCEA example. This one was an excellence problem, and I think it was done very poorly the year it was set in 2020. People really struggle with it. I've said question 1A, but it's actually question 1D. So Joe is travelling at 50 kilometres an hour, sees a pothole on the road 15 metres ahead. She must reduce her speed from 50 to 20 to avoid damaging the car. If the time needed for safe braking is 2.3 seconds, show by calculation whether there's enough time to complete the braking before reaching this pothole. you should start by showing 50 kilometers an hour is 13 meters per second. So we're going to do that, convert the units first. So whenever I convert units, I just write out what I've got, and then I write out kilometers per hour as an actual divided by, because that's what it is, it's equivalent. And then I just change each of those units one at a time. Kilometer, how many meters is a kilometer? It's 1,000 meters. So I just change where it says kilometer to 1,000 meters. Then I can simplify that. 50 times 1,000 is 50,000. And then I can do the same thing for an hour. How much is an hour? Well, it's 3,600 seconds. And I change that, do the maths, 50,000 divided by 3,600 is 13.8 meters per second. I can do the same thing for 20 kilometers an hour, but I'll do it in a few less steps. I'm changing kilometers to 1,000 meters. I'm changing divided by hours to 3,600 seconds. And I get 5.56 meters per second. So I've now changed my 50 and my 20 to 13 and 5 meters a second. All right. Same as before, I want to start with the motion map, make sure I'm getting everything right. I'm starting off with a high velocity and I'm decreasing that velocity, which means my acceleration is in the opposite direction. My acceleration is negative. My velocity is decreasing, but it's a positive velocity still. My acceleration is constant, but it's a negative acceleration. Okay, so now I've got in my head some useful things about the velocity and the acceleration. Let's use some graphs. So I'm slowing down, so my gradient of my displacement time graph gets smaller. I don't know the distance I go. Okay, so even though they give me a distance of 15 meters, that's where the pothole is, but I'm not sure what the car's going to do. I know it has to safely slow down in 2.3 seconds, but I don't know what distance it goes yet. I know its speeds. It's starting at 13.8, that's the 50, down to 5.56, that's the 20, and that takes me 2.3 seconds. I also know the acceleration is negative, but I don't know what that value is yet. Okay, so I want to work out how far I go in that 2.3 seconds. I know the area under that graph is displacement, so I'm going to go through the same process I had before, except this area under this graph is a little bit more complicated because it's made of two shapes. So it's made of a triangle and a rectangle. There's the triangle, there's the rectangle. So let's just work them out one at a time. My triangle is a half base times height. The base is 2.3 seconds. The height is the difference between 5.56 and 3.89, and that equals 8.33. Times that together I get 9.58 meters. And then the blue bit, the rectangle, it's just base times height. So it's just base is 2.3 seconds and the height 5.56 meters. And add those two distances together, and I get 22.3 meters. That's how far I'm going to travel in the 2.3 seconds. But the pothole's only 15 meters ahead, so I'm going to hit it. So we won't brake safely in time. I could do the same problem using an equation. Because I've done my motion map already, I already know my velocity is positive but decreasing, and my acceleration is negative but constant. Alright, so what have I got? I've got the initial velocity was 13.8, I'd already worked that out. My final velocity is 5.6, my time's 2.3, and I want to work out my distance. So which of those equations has all that in it? It's this one here, the one that's missing the acceleration. Put my numbers in, work it out, and I get exactly the same answer as before, 22 meters, which again, it won't stop in time.